Alright guys, here's the start of the second math video. So I want you guys to complete this warm-up down here on your dry erase sheet. If you're going to graph, you might want to use graph paper and do it that way. Or if you're going to use the calculator, you can show it to me on the computer or on your calculator, as long as you show me the solution to this system here. So what I'm going to have you do is have your homework out on the desk. If you have questions on it or certain ones you want to go over, that's fine. But for right now, I just want to walk around and check it. So just take out the homework, put that on the desk, and we're going to have you guys solve this system. You can use any method you want. Okay, so you can use graphing, you can use substitution, or you can use elimination from yesterday, as long as you get me that ordered pair that is the solution to both equations simultaneously. And again, I want you guys to have your homework on your desk, and we'll go over any questions that you have live in class. And if you don't have any questions to go over, you are welcome to go ahead through the warm-up, and once you show me your solution to the warm-up, we'll get started on the video for today. Alright, so today's objective, we're going to learn to solve systems with elimination again, but this is going to be if you need to multiply first. Sometimes we can't solve a system with elimination right away. We might have to multiply the equations first. If, for example, like we have here in this linear system, we can't cancel anything out by adding or subtracting. If I added, I'd have 8x, negative 2y, and 36. And if I subtracted, I'd have 2x, and I would have 6y and negative 4. And so none of the variables cancel out, and that's kind of the point of doing this, to have one of the variables cancel out so we can use it to solve for the other. Okay? But what we can do is notice that the coefficient on the 2 here, or on the y here, is 2, and the coefficient on the y here is negative 4. Okay? So one thing you might notice is you can turn this 2 into a 4. And the way we can do that is by multiplying by 2. But just like with the equations, when you have to do the same thing on both sides, if I'm multiplying this 2 by 2, I also have to multiply the 5x by 2 and the 16 by 2. So the resulting equation is going to be 10x plus 4y equals 32. We notice at this point, we don't have to change anything with the bottom equation, because while my x's won't cancel out, my 4's will if I add them. So if I have positive 4y plus negative 4y, those will in fact cancel out, and I would be able to use 10x plus 3x and 32 plus 20 to go ahead and solve that. So let's take a look at the first example. Alright, so we're looking at multiplying one equation and then adding this. We could also multiply and then subtract, so you guys can kind of mess around with that a little bit. But we're going to start by taking a look at this linear system. And so we kind of have to figure out, before we get started, how we're going to approach this problem. And so I see if I subtracted here, I wouldn't cancel out these x terms, and I certainly wouldn't cancel out the y terms. We would have something left over either way. Same if I add them. I would have 8x, 8y. Again, none of that cancels, so I can't just go ahead and start eliminating here with addition or subtraction. I'm going to have to multiply first. So I'm going to copy down the first equation. I've got 6x plus 5y equals 19. And for the second equation, I've got 2x plus 3y equals 5. And so really we have to kind of take a look at what's going to be the most efficient approach for us as individual learners. And so I can tell you up front, for me, I know that I can't multiply 3 by anything that's an integer, a whole number, to get 5. And I can't do that with 5 to get 3. I could do it with fractions, but that gets sloppy and messy, and you guys know I like to try to avoid that. What I do notice, though, is that this 6 is a multiple of 2, which means there's some whole number I can multiply by 2 to get 6. Any idea what that is? It is 3. So we don't have to multiply the top equation by anything, but we do have to multiply the bottom equation, and that's going to be multiplied by that 3 there. Okay, because that multiplying by 3 will give me 6x. So we're going to go ahead and do this. Alright, so if I do this, I'm going to leave these first equation, the top equation alone, 6x plus 5y equals 19. And the bottom equation getting multiplied by 3 2x times 3 gives me 6x, which is what I wanted. And then I have plus 3y times 3, so plus 9y. And then I've got my 5 times 3, which is going to give me 15. At this point, I'm sure you can kind of see where this is going. I will now be able to cancel these out. But this says add. If you added these, would you cancel them out? No, you would not. You would end up with 12x, 14y, and 34. We don't want that. So this says add, but really, we're going to go ahead and subtract each of these pieces. All right, so if I know that I'm going to subtract the whole thing, I can go through and kind of just put a minus sign in front of all these and turn them into negatives. Okay, and now I can add. Or the other alternative approach would be to multiply this thing by negative 3 in the beginning to use addition. So if I did that, I would have negative 6x minus 9y minus 15, which is exactly what I ended up getting here when I realized that I couldn't combine 6x and 6x to cancel them out. Going through that, if I now combine the like terms after I flip all the symbols for the subtraction, I have 6x minus 6x. I know that that is going to cancel. And now I'm going to combine 5y plus negative 9y. That's going to give you negative 4y. Alright, and so if I'm combining 19 and negative 15, it's just like 19 minus 15. We know that that's going to give us positive 4. At this point, I think you kind of know what's going on, so if you want to skip ahead to the next example, you can, or you can finish solving this on your own, or you can follow along with me. Obviously, I'm going to need to divide by negative 4 on both sides. When I do that, the negatives cancel here, and the 4's cancel here. So what I have left over is y equals, and 4 divided by negative 4 is negative 1. Alright, so now I've got this y equals negative 1, and at this point you know that you're going to substitute this into one of these equations over here. Try to use the regular equations, because if you make a mistake in your multiplication and you use this equation down here, it's going to give you the right answer, but it's not going to give you the right answer to this system. It's going to give you the right answer to your flawed system. So we're going to make sure we use one of the original equations here. And so if I go ahead and I plug the y in, I guess I'll use the equation 2 because I like it for the smaller coefficients. Alright, a little bit easier to work with, I think. And so I'm going to do 2x plus 3 times negative 1 equals 5. So all I did there was substitute the negative 1 for the y. I'm going to go ahead and simplify 2x. And I know that if I do 3 times negative 1, I'm going to get a negative 3. So either plus negative 3 or minus 3 equals 5. Now I see I'm going to solve for x. So because that's the objective here, get the x coordinate of this ordered pair. Alright, and so if I do that, I'm going to have 2x minus 3 plus 3 equals 5. And whatever I do over here with this plus 3, I got to do over here. Alright, and so minus 3 plus 3 cancels. I've got 2x equals 8. From here, you're going to divide by 2 on the left. So you also have to divide by 2 on the right. We find that x is going to be equal to 8 divided by 2, which is 4. Alright, so now I've got x equals 4, y equals negative 1. If I want to put that in ordered pair form for the solution to this system, 4, negative 1. Alright. If you have any questions, make sure to let me know. We're going to move on to the next example. Alright, so this equation, or system of equations, is a little more complicated because we see we're going to have to multiply both equations here. But you also might notice that these are not in the same form. We've got this one up here in standard, and this one in the y equals form of the coefficient of 2. Alright, so first things first, you have to decide whether you want to work with these in standard or work with these in whatever form this is going to be with the y on the left. Alright, so what I'm going to do is I'm going to move this into standard form. So I know that I'm going to take equation 2 and get the x and the y on the same side. So I'm going to take this 2y equals 3x minus 9, and I'm going to get the x onto the same side as the 2y. And to do that, I'm going to have to minus 3x on each side. So 3x minus 3x minus 9. Alright, so over here we see these cancel out. And over here I've got 2y minus 3x. But I notice that this equation up here is x first, y second. So I'm going to have to swap the order here. And it's really important to remember that this negative sign goes with the 3x. So negative 3x, and we see that the 2 is not negative, so it gets a plus sign. And equals, and we know that all we have left over here is negative 9. We know that we now have two equations in the same form, so now we're going to have to compare them and see which ones we're going to multiply. Alright, so we'll get a little space here. I've got my first equation, which is that 4x plus 5y equals 35. And I've got my now new equation here, which is negative 3x plus 2y equals negative 9. And so now we realize there's nothing we can multiply negative 3 by to get 4, or vice versa. There's nothing you can multiply 2 by to get 5, or 5 to get 2. And again, that's of course ignoring the possibility for decimals and fractions. So what we can do though is we can multiply this one by 5, and this, or by 2 rather, and this one by 5, or we can multiply this top one by 3 and this bottom one by 4. So basically we're just multiplying them by each other. And so what I'm going to do is I'm going to work with the y's this time. And so I'm going to multiply this top one times 2. I'm going to multiply the bottom one times 5. Okay, so I just flip-flop these. And if I do that with this equation, I'm going to end up with 8x plus 10y equals 70. And so down here, I'm going to end up with negative 15x plus 10y equals negative 45. Alrighty, and so at this point we see that if we subtract these, they are going to cancel out because these 10y's are going to cancel. So I'm going to go through and flip all the signs. So this negative 15x becomes a plus, this plus 10y becomes a negative, and this negative 45 becomes plus. Now when I combine like terms, I've got 23x. These are going to cancel. And over here, I'm going to have 115. At this point, I see that I would divide by 23 on both sides. These cancel. X equals 5. And at this point, you're going to substitute this back in and solve for y. I'm not going to show you that because I know you guys have seen it a bunch of times already. If you do need to see it, call me over and we will work our way through it. All right? Finally, I want you guys to take a shot at using any method to solve this. I'm going to help by walking you through setting up this equation a little bit, not too much, and then we'll get on to the homework problems, okay? So we see a library is having a book sale to raise money. Hardcover books cost $4 each, and paperback books cost $2 each. A person spends $26 for 8 books. How many hardcover books did she purchase? So, you know, if you're going to use H for hardcover and P for paperback, that's cool. And you know, you can go ahead and do that. What you need to know is that you should define your variables for H and P, or you can use X and Y and define them that way. But if you know that hardcovers cost $4 each, you should start off with a 4H or 4X. And you know that over here, if the paperbacks are $2 each, you're going to use a 2P or 2Y. And it tells us the total is $26. Now the other equation is kind of hidden in here. It says the total is 8 books. Well, how do I write an expression that shows the total of books? The number of hardbacks plus the number of paperbacks totals 8. There's your system. Get to solving. For the first homework problem, I want you guys to use any method to solve this problem here. So you can use, again, you can use the calculator, you can use graphing, you can use substitution, or you can use elimination. And you just have to show me your work and your ordered pair solution and explain to me how you did that. Alright, and so we've got this last homework problem here. Again, you're going to use any method to solve it. This one's a little more complicated because it's got a word problem and it's got a table on it. Okay, so if you do need a little bit of help, don't be afraid to ask and let me know what's going on, and I'll do my best to help you out. Don't forget to check the website for notes, and you can always rewatch the video.